Welcome to IT in Motion, where we make IT interesting and informative. My name is Josh.
And I'm Patrick, and our guest today is Gavin Cohen, VP of AI Product Management at ScienceLogic. How you doing, Gavin?
Very well, thanks. Thanks for having me on, Patrick and Josh.
Well, we're glad to have you. We're going to get started with a little game to get to know you. You had mentioned to us earlier you had interest in playing the guitar and things like that. So we're going to ask you some guitar questions, and we'll kick off with the first one. If you could only play one guitar for the rest of your life, which one would it be and why?
Actually, when I said interest, you shouldn't confuse interest and ability and skill. So the answer to that would be actually any guitar where I could play a meaningful sound from would be my ideal guitar.
Sure. So it's something where you're kind of in the early phases learning the skill.
Well, I learned a long time ago, and I used to play a lot more. And every now and then, I sort of blow the dust off an old guitar that ended up traveling with me. But yes, it's a work in progress, probably a permanent work in progress.
If you could
Yeah.
jam with somebody, living or dead, who would it be? Who would you sit in, and what song would you play?
Um, well, it's funny because he's not known really as a guitarist. He's actually a bass player, but I'd probably Paul McCartney because just for a million reasons.
Yeah, I mean, it's hard to get more impactful on music than the Beatles, right?
Absolutely. Yes. Yes, indeed.
All right, well, very good. We're gonna get to know you a little bit now. You're of course now vice president over AI here, but can you share your journey with us, your early experiences? How computers and things shaped your career?
Yeah, I mean, my father was, and in the very early days was at IBM, and so he ended up starting his own business. So very early on, before sort of PCs and everything were a thing, he brought home kind of a very early CPM based, system that I got to play around with. And I was pretty young at the time, and it just sort of fell in love with it. And I think eventually they had to take it away because my school grades and everything plummeted, and and
Classic, yeah.
a lot of people haven't. But that's I was always interested in technology and things around it. So, but that really cemented it. And then I carried on and studied computer science and so on, and that's where it all started.
So you started. You started. I'm assuming sort of as a programmer, right? And you've had a lot of different roles. You've had a chance to move through sales and pre-sales roles and product management. And what really motivated that? Like, what drove you throughout that set of different roles, and how did that really benefit your career?
Yeah. So actually, my love was programming. I didn't actually ever work as a programmer for very long. I paid my way for an overseas trip, and all my sort of early work was programming. And actually, at university as well, I had lots of part-time programming jobs. Once I actually sort of settled down to actually work properly, I got a job as a programmer, but it was for a very small company, and they needed people to go out and visit customers and explain what to do. And so very quickly, I found myself much more on the outward facing side than actually programming. And then every other opportunity that came my way seemed to pull me more and more away from being hands-on and more into the pieces around it. So talking about the technology, working in pre-sales, product management, and so on. So I've always tried to keep a technical background, but I haven't worked as a programmer since the very, very early days.
So you really your process your path was more from the technology into getting the technology into the hands of people who could use it to really make it useful and actually have people to actually be able to change their businesses or the way they're operating, not so much just sitting in and writing code.
Yes, exactly. You got it.
Very good. When did you first get the entrepreneurial bug, and can you share that story?
Yes, I mean, I've been acquired. I think joining ScienceLogic, I think was my fourth acquisition. So I haven't really had a lot of experience in big companies, but I've been acquired by big companies a few times. Um, I was, from the very early days, we were in a little reseller business that got acquired. But then I'm Australian. I moved to the US the first time in the early 2000s and joined a seven-person startup, which ultimately building virtual tape libraries, so using disk to emulate tape, which was kind of pioneering at the time because disk was starting to get cheaper and tape was the way people stored long-term backups. So we did that and got acquired by NetApp. So that was my first experience into a big company. But NetApp was, I think they were around 4,000 people at the time, but they were an interesting company because they operated like a really fast-moving startup and it had just an incredible culture. So I learned a lot about sort of all the disciplines that you need in a big company, but without all the constraints of process. And then after joining NetApp, I left to join Nimble Storage. I'd moved back to Australia by that time, so I helped set up Nimble Storage in the APAC region, and then ended up. My role was actually supposed to be in the US. So after a year or so of that, I moved back to the US to take on a sort of a product strategy role, and then I ended up leading product and solutions marketing at Nimble Storage when they got acquired by HPE. And then a few of us left to join Zebrium. So Zebrium was founded by Larry Lancaster, and the whole rationale for it at Nimble Storage, as much as it was a storage company, storage largely was becoming commoditized. But what really set Nimble Storage apart from any other vendor was they, as a company, right from the beginning, sort of through the brilliance of foresight, every storage device sent huge amounts of telemetry back to base. And they actually did stuff with the telemetry. So Nimble was able to predict and prevent most incidents before customers knew they happened because it watched the telemetry very carefully, and they had an enormous amount of instrumentation and rules in place at the back end to pick things out and then notify customers when there were problems, or proactively fix things or send new disks when things were failing, whatever. But the bottom line was the Nimble Storage arrays were way easier to use than anything else, and way more reliable and in every sense. And the support experience was just phenomenal. Nimble had an NPS and something ridiculous in the 90s because they just did such a great job of that. And Larry's whole vision behind that was what Nimble had built was very homegrown, not homegrown, but it was designed purely around the idea of storage telemetry and what you have to do with it and all the rules around it. He really wanted to generalize this and use AI to solve the problem and make it suitable for everyone. And that led to, he started Zebrium and I joined a little bit, in the very early days, but Larry had already been working at that problem and just started the foundation of the company. So I joined just before Zebrium got funded the first time. And the idea was to make that more ubiquitous and take it to the market as a tool that could watch telemetry unsupervised and pick out problems. We focused on the log problem because logs are the most rich source of telemetry, and actually most root cause investigations, when they can't be solved easily, end up someone looking in logs. And the idea was to be able to pick out potential problems in logs and then figure out all the details in the logs autonomously. And that's really what Zebrium did. And we went through a few different sort of versions of that, but ultimately that led to being acquired by ScienceLogic. And that's how it came to be here.
It's interesting, the really getting the bug for telemetry. There was a time, I think, in all of our careers where having really great data about the way that systems were operating was nice. It was convenient. It was cool. But today, with the level of complexity that we've gotten to with operations, a vendor that provides great telemetry as a part of their infrastructure really is a mark of maturity, because it makes it much easier to integrate. And to your point, in this case, like being able to have access to lots and lots of data from multiple sources is how you actually get to the sort of operational insight that really makes a difference.
Yep. And actually what we learned very quickly, and that's sort of in the ideal world, you want to do that. The reality is mostly when you talk to anybody in a vendor building products or a customer with a big IT shop, the telemetry is what the telemetry is. It's whatever was put there when things were put in place. So really the trick now with the AI and with the technologies that you use to interpret the telemetry, it's really making the most of it. And I think that's, in a sense, Zebrium was very visionary in doing that, because in collecting logs are messy and unstructured and voluminous and mostly noise. I don't know if I got that word correct, but huge volumes, mostly noise, mostly spammy, often have incorrect severity. So everything ugly about telemetry is in logs, and yet they're so useful if you actually look through them. And the idea was to be able to handle all that and figure it out. So essentially know what patterns were noisy and log lines, so be able to categorize everything and then pick out the stuff that actually mattered from a diagnostic perspective. I think that's really what you have to do with any kind of telemetry. You have to assume that what's there is what's there. It's very hard to get people to change it and change how they create the telemetry and build it. Really more look at how you can get great insight. Obviously, ideally, you'd have perfect telemetry, but that's difficult because it involves customers to change.
Yeah, well, and you kind of brought up the key point there, right? Which is this data has been available for a long time, right? Things are always throwing off telemetry, but we haven't had a way to go really deal with it other than someone has an idea and they search through logs, sometimes in long, painful manual process. Now you're bringing AI into it, which is what Skylar's all about, and Zebrium before that. But I also know that there's a lot of kind of AI brand washing going on out there. Do you have any advice for people who are interested in bringing AI in, of how they can get an actual AI solution versus something that says AI but isn't AI?
Yeah, look, the AI washing or whatever you want to call it, it's everywhere, and people call all kinds of things AI that are not AI. But really, the goal here, right, is people want things to run smoothly. And so when there's a problem, they want to be told there's a problem. If there's something that's going to break, they want to be told something's going to break. And the way people have been doing a lot of that for a long time by creating rules, right? And there are lots of things where rules actually are great. Like you could say, if um, disk is above 90%, it's a problem, I want to know about it. And so, a rule can really help you. Or if some event occurs, it means that something's broken. So tell me about it and alert me. So rules are fantastic, but there are a lot of things where rules don't make sense. When things change, period, like 3 orders an hour at midnight might be normal, but 3 orders an hour in the middle of the day might be completely abnormal. So you'd want to know if in one case it was a problem and in another it wasn't. So there are all kinds of things where rules don't necessarily work. And really what you want to do is think about having solutions that help give you, something better than what you can do without them. And so the whole approach we're taking, and you mentioned Skylar, which was the big launch at ScienceLogic from 2 weeks ago. The whole notion there is really there's lots of insight, lots of telemetry and data that's being collected and being collected. And I think one thing ScienceLogic's always done well with is it's been around for 20 years, and it has this amazing ability to collect telemetry from almost any kind of device in almost any kind of way. So it's hugely flexible in bringing data in, and it's over the years it's built all kinds of amazing out of the box ways of dealing with legacy switches and devices that you can't even buy new anymore, all the way through to containers and microservices. So you have all this data, and the engines designed to process it have been doing a great job. But really, what we want to do now is revisit that data with high performance analytic and AI engines, reason over it better, and then get more information out of it. So the whole goal of what we're trying to do, and I know this is waffling from the question you said, but really the way we're thinking about this problem is we want to take all the telemetry, we want to be able to do new things with it by reasoning over it and performing new analytic techniques and ML techniques on top of it to extract insights, and then to bubble them up and correlate those insights and figure out what's important and what isn't, and reason over it. But we also want to pull in, and this is something that I think not many vendors have really been talking about, we don't just want to look at raw telemetry to make these decisions. We want to look at all the other important information that goes on around it. And so if you think about in a company that has, whether it's a development environment or an IT environment, you have your products emitting telemetry, but you have product documentation in plain language. You have support tickets in plain language. You have bug databases that document known problems in a different place. And you have all this kind of stored knowledge that's highly valuable when you're looking at trying to make a decision on a problem. So imagine these ideas where you can spot in the telemetry that something's happening without creating a rule, and you spot it because you see the patterns changing. And then you can go and match that to something that's in a bug database where it's a known problem, and instead of making someone solve the problem and search for solutions and so on, you pick out the problem and then you point them directly at the bug that explains what the problem is. And that's really what Skylar's all about. It's all about all these different things we can do with mapping and reasoning over both telemetry and all the surrounding, what we call stored knowledge or contextual stored knowledge, to come up with a better picture of what's happening. And the goal there is really three simple things. If there's a problem, we want to tell you there's a problem in simple terms. We want to tell you what caused it, so the root cause, and we want to tell you how to fix it. If there's any kind of sane way we can get to that based on information that we have available to us. So that's the first goal. Pick up problems, tell you what caused them and how to fix them. The second thing is we want to accurately predict things. And that's a really interesting one because many outages are caused by simple things that you should know well in advance. So if there's a slow memory leak, why wait till you get out of memory issues or things, CPU gets pegged and brings everything down? If you're actually watching memory closely, you can very accurate, if you see it's growing by a small amount every hour, you can very precisely predict that it's actually going to run out in 16 hours. So instead of waiting till it crosses a threshold, imagine, and these things, it sounds really simple, but not many people do it well, being able to tell someone well in advance, hey, your memory is going to run out in 16 hours. You better do something about it now and remediate it. Oh, and by the way, this is the cause of it. There's a memory leak that, we're seeing because of some other message from somewhere else or some other piece of telemetry. So that's really what we want to do. So the second thing we want to do is, where possible, we want to predict things in advance, tell you what the problem is and what's caused it, but also tell you how to prevent it from causing an outage. And that should clear up a lot of things. And we're already doing that as the first piece of Skylar that we're releasing, Skylar Analytics, which is we're building in very well modeled ways of predicting some key resources like memory and CPU and some of the interface data and disk, because we know time and time again they're things that cause problems, and if we accurately model them, we can do a lot with them. So that's what we're doing. So it's the idea about predicting things and preventing them from happening. Then the third thing is, for everything else, we just want to be able to accurately answer questions that people need to keep things running optimally, but doing it not just with the context of what we see in telemetry, so not just being able to produce dashboards, but bringing in the context around it, the tickets and the documentation, so that we can do it within the confines and the language of what a company wants.
It's really interesting. You started talking about rules, and then increasingly we're talking about knowledge, and we're talking about conversation, and talking about KB articles, and about plain language communication. And it sounds like a big part of this is that idea of getting away from sort of the false deterministic opinion about rules, right? Like, I've spent a lot of time, I've invested a ton in these handcrafted rules, and so surely I have encapsulated all the knowledge about my operations. And in a way, the more you invest, the more your cognitive bias is toward that conclusion. And it sounds like you're saying that the real value of AI there is to be able to be more flexible and to move away from that mindset of hard and fast rules and limits and triggers, and instead go to a curated curiosity about the way that the data is speaking to the organization about the way that IT is operating.
Yeah, to some extent. So let me say as well, rules absolutely are important. In fact, rules are probably the foundation of picking things up. If you know there's something deterministic that causes a problem, the rule is probably the best way of catching it, right? It's deterministic and it's definable. So for things where rules make sense, they're probably the best mechanism of detecting problems. We can then use predictive techniques to predict things that are trending towards where those rules are going to trigger. So there's all that. But also you want to explain it. So here's the classic thing. The rule says if latency is above 100 milliseconds, it's a problem. My website's going to run slowly, right? So you want to alert people when it's above 100 milliseconds. That's good. But that's a symptom, right? That's the latency's gone up. The cause of that could be there's an infinite number of things that could cause it to go up. So what we want to be able to do is you might trigger a rule that says there's a problem. So that's used. The rule might be perfectly fine for that. But now you've got to figure out and find the needle in the haystack of what caused it, the root cause. And that's where you can let the AI go and reason over the rest of the telemetry. So you can say, well, I've got a specific thing that's broken at 10:43 a.m. Now I can look from before that at all the other telemetry and all the other things and pick out the patterns that might explain what caused it. So use AI in that sense. And then the text information is interesting because obviously you'd have to have been living under a rock not to have seen the impact of ChatGPT and language models and everything else. The technology is amazing. It can reason over all this information and come up with simple explanations and summaries and so on. And the trick that we're doing to make that work well, because we are part of the Skylar piece, and this is the piece that's coming out in our subsequent releases, is it will use an on-prem language model that's very well tuned to work with the kind of data that we have, telemetry and the stored knowledge, and it understands that and knows how to reason over it. And then it uses lots of techniques like RAG and other things to bring in the dynamic data to extend what insights it can pull out and what summarization it can perform. But really the trick is also that to make a language model behave well, you have to feed it the right stuff. So what goes in is going to determine what the language model produces at the end. So not just prompt engineering, but thinking about how do you make the telemetry, how do you summarize the telemetry well enough that you can feed it to a language model? And just as a simple example, if you think about language models have context windows. So you have to be able to fit everything you want to ask of the language model within a context window. And they're usually relatively small, and they're measured in tokens, whether it's 50,000 tokens or 100,000, or even some of the newer models they're talking about 1 million tokens. But it's like the short-term memory of the language model. So whatever you pack in there is what it can reason over. And even within a context window, when they talk about a 1 million token context window, the memory of the language model isn't perfect. So it'll remember some of the more recent things, and it'll be less, there are lots of studies on this. It doesn't treat the whole context window correctly. Why am I saying all this? Because if you were to feed raw telemetry to a language model, as you might want to do, you would blow up the context window potentially in seconds. So can you imagine big environments that emit, billions of metrics every second and billions or millions of log lines every second? You might fill up the context window multiple times a second, even in the biggest models. So how could you ask it to reason over that? So really, the tricks and the techniques that we're using is to use multiple different ML techniques to first summarize the telemetry, get it down concise enough where we can pass it into a sane, well-trained language model, and then get really good sort of information out of it, and that's how we're thinking about it.
It's interesting, you're talking about context, for the model, and especially I think we see this a lot in sort of real time streaming analysis. But I mean, you come from a storage background and especially telemetry background, so you have been packing away operational data for a while and building data lakes, right? So one of the things that's really valuable to organizations, obviously, is they have lots and lots of data, in some case spanning years. So what's your approach to making that actionable, being able to really do something with historical data, not just live streaming data, to really provide that longer term awareness and context of the way that IT operations runs?
Yeah. So there are lots of really interesting techniques that these AI models and language models help you with. But what you can do is you can have massive repositories of information that's the stored knowledge, and obviously not all of it has the same value and so on. But um, the way that search is becoming now is you do semantic searching, so you don't have to have exact phrases or exact terms. You can search based around concepts and things. So we're using the same idea. So we summarize the telemetry. We can then, get the language model to reason over it. We can use RAG and other techniques to then look across the other stored knowledge and pick up what's relevant. And all of this we can then decide on, or the language, the AI decides what's most important and what's most relevant to then serve up and pass through with the same answer. So there are lots of ways you can do this, and it's pretty exciting times because it's all evolving very quickly. So
Yeah, absolutely. It's really clear that we're on the cutting edge of this technology right now. And, a lot of these terms that you're just mentioning that we use to kind of process this data, a lot of them didn't exist a year ago, 2 years ago, 5 years ago, right? These are all terms that have recently, gone from someone's mind to an academic paper to production in just a very short period of time.
yeah, yeah.
Um, Along those lines, we've got one final question for you, which is, what trends do you see for the future? Right? I mean, we are all inundated with this news of AI and all the hype that's going on and everything. But what trends do you see coming in the future?
So it's funny because I mean, I think this is one where even the future, you don't even want to try and trend out because it's playing out every minute of every day, like all these new things that are being done with the AI. And our belief and what really was key to the whole concept of Skylar is, as a company, we're taking a very different approach to how we think about AI to, I think, what the rest of the industry's done. And what's really interesting is most of the vendors in our space, when they talk about what they're doing with language models and Gen AI, they're really adding in what's called like an AI assistant. And I mean, you've seen it from websites. You have the little panel that pops up and says, any questions, right? And inside a product, you might have some complicated monitoring tool, and you have a little panel in the bottom right hand side. So instead of having to figure out how to generate some complex dashboard chart of latency of your top 10 devices in data center A over the last 3 months, which might be a query that takes you forever to construct, the idea of an assistant is you just type into the little panel and you say, generate dashboard of top 10 systems, enter, and it just generates it for you. And then you can say, zoom in or zoom, whatever. You can converse with it in plain language. And you can say, well, based on all the different things you're seeing on the screen, what can you tell me? And so you can do things like that, which are really no different to what people do manually. It's just that the assistant makes it plain language and quicker. And that's the sort of cutting edge approach nowadays to layering Gen AI and language models into a working tool. And that's kind of obviously the temptation at ScienceLogic. We have a fantastic platform. What should we do? Well, we could just add an assistant. The thing is, the assistants still require human expertise to figure out what questions to type into that assistant. So the fundamental thing we do, and if you said, what do we think the trend is? I think it's along the lines of what we're doing with Skylar. And I'm saying that partly because it's self-serving, but I really believe this is the case. We're turning it around because we're not building an assistant. We're building what we're calling an advisor. And the idea of the advisor is you don't have to, it's not triggered by asking a question. The advisor is looking at the same telemetry and has the same purview of everything as the human, but it's uncovering what's important and it's coming back to you and telling you what it thinks is important, almost like it's giving you the answer to the same question that you would have asked if you were an expert, but you never had to ask the question and you never had to distill down what you needed. It just told it to you. So that goes back to those three things I said. If there's a problem, we just want to tell you there's a problem, what caused it, how to fix it. If there's going to be a problem, we want to tell you that too, and so on. So we really, ultimately, that's what we want to do, and I think that's where the future is. It's going to take away all the mundane, difficult things that you have to do when you're troubleshooting problems and uncovering problems, and it's just going to give you those answers and be able to explain why it it got to that and help you fix it without needing this deep tribal knowledge and deep expertise at every step of the way.
Well, that's a really interesting vision. Gavin, thank you for joining us. We really appreciate you taking the time to sit down. If people want to find out more about you or learn more, where can they go?
Great question. I mean, I'm on LinkedIn and obviously available through ScienceLogic, so please ask away.
All right. Well, thank you.
Thank you,
All
mate.
right.
Thanks, Gavin.
Thanks so much. Thanks for having me on.
Thank you for joining us today. I hope you enjoyed today's episode. If you did, please subscribe or hit like in your favorite podcast app. We're on Apple, Spotify, Stitcher, YouTube, iHeartRadio, and many other podcast platforms. We release new episodes on a regular basis, and you can find more of our episodes at sciencelogic.com/podcast.